The binomial table, it's a table consisted of rows and columns. This table gives the cumulative probability. This table is ready to use for obtaining the binomial distribution. It gives us the cumulative probabilities. Actually, we discussed the cumulative probabilities previously in our previous lectures. Actually, if you go back to our classroom lectures from the beginning up to now, this cumulative frequency is from x equal to 0 up through some specific positive numbers. Now, in order to understand this table, we do need to have to solve some problems. Now, the problem or the example that will be taken right now, our previous example that's talking about the immunity against some certain disease. Actually, that information that from that example that we have previous in our previous slides, actually, x equal to 4 from the example, n equal to 10, and p equal to 0.3. And if we go to back directed to the cumulative frequency, we found we are willing, if you go back to the example, we are willing to solve, or if we pick 10 samples from this population, what's the probability to be 4 of them actually to be immune? And since you know that the probability of this population is 0.3, 0.30 or 30% of this population are immune against certain disease. What's the probability if we pick 10 samples from them? What's the probability to obtain 4 of them are immune? Now, we do need to solve it by using the table, binomial table. Returning back to the cumulative frequency, we found that P, the probability of x equal to 4, can be found by subtracting the probability of x less than or equal to 3 from the probability of x less than or equal to 4. And the probability from the table, if you go to the table by using n and x, the n, the number of 10, okay? If you go back to, if you see that table, binomial table, the probability of x equal to or less than 4 equal to 0.8497, and the probability of x less than or equal to 3, from the table we will get this number. This number is 0.6496. Now we do need to subtract them from each other, and it will yield this number, this value. It will yield 0.2001. And if you return back to the result that has been solved by using the combination equation, okay, or the factorial, it was 0.2001. This is the final answer, and it is very easy to use the tables rather than using the equation, but you do need to know both of them. This is the table. This is the cumulative binomial table that has been uploaded within the book, the textbook that I have been uploaded, that has been uploaded actually previously in the e-learning. You do need to return back. It's called Table B. You can take it from there. And this is, as you see from this table, you can see that it will give us the cumulative binomial probability distribution. And this is the binomial distribution curve. You can see it consisted of rows and columns. Columns here will equal to x. Okay, this is the n equal to 5, and this is the probability that we are using. So we can use it directly to obtain the cumulative frequency. And also, I have drawn this table for you just to understand. And we can see that it is a lot of n's. If you go to the table, it's a very large table, and you can use how many n you have, and any number of n, any number of probabilities, and any number of x's. Now, suppose it's known that in a certain population, 10% of the population is colorblind. If a random sample of 25% or people is drawn from this population, use binomial table to find the probability. that the first question, to find what's the probability to find 5 or fewer will be of colorblind. The second, 6 or more will be colorblind. Now return back, we do need to understand this question first of all before solving it. Now in this population, 10% of this population is colorblind. This is the first information. If we select randomly a sample of 25%, this is our sample. It is 25. They are drawn from this population. This population, again, this population, 10% of this population is colorblind. If we pick 25% randomly from this population, what's the probability to obtain 5 or fewer? 5 or fewer will be colorblind from this 25%. Okay, the second question. 6 or more from those 25 people, 6 or more will be colorblind. We do need to solve this problem or this example by using the binomial table. We can go directly to the table to obtain A. 5 or fewer will be colorblind. This probability is entered in the table. No addition or subtraction is needed because we need 5 or fewer, and we do need to recall that. Just to remind you, the table is a cumulative frequency, تراكمي. Now we do need 5 or fewer. What does it mean? It means that x equal to less than or equal to 5. Less than or equal to 5. In here from the question is 25. The probability of the colorblind is 10%, and directly from the table we can obtain the probability of x equal to less than or equal to 5 will be 0.9666. It's a direct question. We directly pick this number from the table, and that's it. Now, for B, 6 or fewer. Return back to my previous lecture. When we solve such problems, I told you it is a complementary probability. Complementary probability. And since the cumulative frequencies are summation all previous from the first with the second, the first and the second with the third, and so on, you can see the probability of obtaining x is greater than or equal to 6 will equal to 1 minus the probability of P, probability of less than or equal to 5, because we are asking about what? About x greater than or equal to 6. We do need the extra values, not the previous values from the table. So it's 1 minus the probability of being less than or equal to 5. From the table, we do need to pick the probability of less than or equal to 5. It will yield 0.9666, and subtract 20 from this amount, it will give you this value, which is 0.03334. So this is a complementary probability. All the summation of all probabilities will yield 1, equal to 1. This is main characteristics of the cumulative or binomial distribution as we discussed previously. So 1 minus this value will give us the result of this. Question 3. Between 6, what's the probability to be? Between 6 and 9, it's inclusive حصريا, will be colorblind. What's the probability from those 25 people to be 6 and 9? Between 6 and 9, ما بين 6 and 9. It's inclusive حصريا. So in here we do need to subtracting the probability that x is less than or equal to 5, because 6 is included. So we take less than or equal to 5, and also 9 is included. We do need to obtain the value that x is less than or equal to 9. from the table directly, the probability of x is greater than or equal to 6 or less than or equal to 9 will be the probability of x equal less than or equal to 9 minus the probability of x less than or equal to 5. And from the table directly, you can find the probability here from the table of x less than or equal to 9 will equal to, from the table, will be 0.999 minus also the probability here 0.966 also from the table. You can take it from the table, will yield 0.033. This is the main answer of this question. For what's the probability if we take 25 persons or people from this population, that is of 10% of them are blind, color blind, what's the probability to obtain 2, 3 or 4 will be color blind. هاي ما احتمالية انه يكون 2 3 أو or 4 will be color blind. To solve this problem, we do need this probability that is Sx is equal between 2 and 4, because 2, 3 or 4, the probability, we can analyze this question by in this way. This is probability that x is equal is between 2 and 4. Now the probability by using this formula of x is greater than or equal to 2 or less than or equal to 4 is the probability of x less than or equal to 4 minus the probability of x less than or equal to 1. Why we add 1 here? Because 2 is included. It's a cumulative frequency. 2 is included. So we'll take the number before 2, which is 1 right here, and directly from the table you can find the probability of x is equal. Of course, we do need to go back by using the certain x numbers, the n and x and the probability. You go directly and find this 0.9020 minus 0.2719 will yield this value. This again, 0.2712 is the probability of x is less than or equal to 1. All of them are from the table. This is from the table. You can see them all, and this is a sample of a cumulative frequency binomial distribution. You can find that n equal to 25 and probability is equal to 0.02, 02, 01, 02, 03 or up to 0.10, and x's are from 0 up to 10.